like to move on and introduce Professor Arslan, who's the Deputy Under Secretary of the Ministry of Education from Turkey. Professor Arslan.
Thank you very much, Mr. Chairman. Excellencies, ladies and gentlemen, good evening to everybody. It's quite a little late, but we beg you were a little patient more, say about an hour, because actually we are discussing one of the most important issues in inclusive education here. Actually, when we talk about inclusive education, everybody talks lots of things, but before including the students into the school, actually, we definitely need a physical environment first. So unless having a physical environment, a proper, a safer physical environment, we cannot talk about the inclusion of the education. So that's why it's one of the important issues, I think, in this conference. So what I will do is, when you ask the inclusive education, it's actually similar to describing an elephant by a blind. So they ask one of them, he holds or she holds only the airs, and it says it's like a plate, the elephant. But what we are going to talk, we will talk about the legs of the elephant, which is the building itself. It should be safe first to get an inclusive education. So what I will do is, I will share some experience that we are having in Turkey and what we have in the past and what we are proposing in the future. So this is the earthquake fatalities actually suffered within some countries. I'm not giving the first one to Japan and Chile and Mexico, and I'll go a little closer to Europe region. The third one, Iran, Italy, the fourth one, Iran, and the other one is Turkey. The number of fatal earthquakes, recent earthquakes, which is about over 100. So the fatality is about per million of population per year is about 14 to 15. So if we go to another statistics, the first one is smoking 10 cigarettes a day. It kills 5,000 people per million. The other natural causes aged 40, over 1,000. Road accident in Europe, 125. But if we go below, the actually earthquakes comes to 5th or 2nd stage here. But when we consider the loss in economy as well, that goes to the top here. So these are the individual actually acts. So safe school concept should be considered as a part of inclusive education. We have to actually underline that. And this is actually one of the major causes of exclusion from the school. So in Turkey, actually, we have, starting from last century, if you consider just one past century, about 76% of the natural disasters comes as earthquake, 10% landslide, and the others actually happens. If you look at the earthquake a little closer here, this is the Earth map, and the occurrence of the earthquakes are shown in black dots. Even it's impossible to see some of the countries because of the black dots over there. So the number of the earthquakes is starting from 1963 till 1998. It's about 360,000 earthquakes, so which is located in the world right now. 96% of the land area of Turkey is at risk from earthquake, and 66% of this hazard area is within a close range of active faults. And also large-scale earthquakes occur at any time in these areas. There are 70% of the country's population lives, particularly in Istanbul region. 75% of damaged buildings and 64% of total disaster losses in the last century are due to earthquakes in Turkey. Well, if we look at Anatolia, Anatolia is exposed to considerable earthquake risks due to its geographical location. And this is the picture of Turkey in terms of earthquake occurrences. If you look at the west, you can see a very, very dense occurrence in the earthquake, and when you go to the east, it's quite a little less density. So that was the past. So what we are expecting in the future, this picture shows what we are expecting in the future. Actually, this fault map, or the green areas, shows the active faults that we are expecting an earthquake within very short time. Say tomorrow, next year, the other year. But it's not longer than 20 years or 15 years. So we are concentrating on those green dots first. That is the beginning of our work at the moment for future work. So the statistical facts about Turkey: in every 8 months, one heavy earthquake occurs, and results collapse of about 6,000 structures or buildings and about 1,000 casualties average per year. So the result of great earthquake in 1999, total of 52,000 damaged buildings actually we have, and 70% of those have light and medium damage, 25% has heavy damage, and 5% has very heavy damage. Floods are also another consideration, particularly in the north part of Turkey, and the landslides are also another concept, but the earthquake comes to first as similar to the other countries actually. So what we have we have a couple of heavy disasters in the near past, starting from 1992, 98, and 99, year 2004 and 5. So some of them are earthquakes, some of them are landslides, and the others. And Istanbul is a big consideration according to our scientific survey and investigation. We are expecting a big earthquake in Turkey. In Istanbul region, and as you know, one of the largest cities in the world, about 13 to 14 million people are living there, and which is 20% of the Turkish population. And also more than 40% of Turkish GDP is generated in that region. That's why in economic consideration also that information is also quite important. So the occurrence of the earthquake in Istanbul compared to this degree, like San Francisco, Los Angeles, and Tokyo cities. Probability of occurrence, just one example I will give and pass this. Probability of occurrence of a large earthquake in the next 30 years is greater than 50%. So which is, you can imagine what we are facing at the moment. So what happens if that earthquake occurs in Istanbul? In fact, after probably say about 7.5 Richter scale earthquake occurs, approximately 70,000 dead we are expecting, and 120,000 injured heavily, right? And direct economic loss is about $30 billion US. So what we do, you know all those information. What we have done, we start to change the regulation actually. The first earthquake regulation starts in 1906. After the San Francisco earthquake actually, all the scientists and the engineers work on the earthquake engineering actually. But the second work stage starts with the Kobe earthquake in Japan in 1994 or 5. Because the physical properties of the earthquake is changed a bit after that earthquake. And we put a new code after those earthquakes. Japan earthquake, and after the Turkish earthquake, we changed the existing earthquake rules. So we have to start from there. We have to have a source to investigate all the buildings, whether they have enough strength against earthquake or not. Well, and after that, we had to wait for several years, which is about 7 years, 6 or 7 years, to have a code dealing with retrofitting. That's also important. And we right now have